So in today's class we will see text classification, and we will also see how do we apply the naive Bayes text classification algorithm. So let's see, why do we require text classification. There are a lot of problems in which we apply it. So for example, we have a spam and we want to identify whether a particular message or an email is spam or not. So we inspect the email. For example, in this email we can identify some features, and then we can see that those specific features are signifying anything that may be related to a spam or not. For example, there is no addressing to a person here, so this is just great news. There is nothing like sir, or there is no name here, or no Mr. or Mrs. something. So that is not something that is in general. So this is something that is particularly different from the general writing, right? Similarly, this is a URL. This URL may not be relevant to the person to which the email is directed. And similarly, we can see the subject. There is no significant information in the subject also, and this again, the recipients are not open here, they are undisclosed. So there are a lot of things that can be taken into account as features, and then we can assign those particular features some kind of class, whether it is a spam or not. So if this, for this particular, I will take this subject as a feature, I will take the recipients as a feature, I may take the addressing as a feature, I may take if URL is present or not as a feature, and particularly I may also take some particular pattern in the URL and some other pattern in the text, right? So I can identify those kind of features, and for this particular set of features I may assign that this is a spam, right? And for other email in which I identify that these things are very normal, and these in case of subject we have a request for some, suppose budget allocation, and we have in this to like president at the rate something, and then we have vice president at the rate something, like so we see that this kind of information, and here we find out sir, and then we don't have any URL. So these kind of information will tell us that this email is not a spam, right? So that is the spam detection. Then in another problem that was very back in 1787, there were some letters called as Federalist papers written by some people they were trying to convince the New York to ratify the US Constitution, right? So there were lot of papers written in which 12 papers were not able to identify currently. In like later, after writing this paper at a later time, people were not able to identify which papers were written by which person among these three, right? So 12 papers, the authorship was in dispute, that these 12 papers may be either written by J. Madison or Hamilton. So in 1963, these Mossler and Wallace, they used these Bayesian methods. Specifically, they used the naive Bayes, and they probably identified and solved this problem, that these 12 papers were actually written by these people, and they were able to identify them. So this kind of problem is called as authorship attribution. This problem is called as authorship attribution. So in current scenario, this authorship attribution problem is used to identify that the particular given text is written by that person or not, right? So there may be some scientific documents, there may be some very high profile letters, so that may also be identified that whether they are not forged and they are written by the actual person or not. Then gender identification. So actually this is author gender identification. This is author gender identification. So some text is written and that text is so that particular text is written by a male or a female. So there are some kind of characteristics that are being identified in text written by a male and the text written by a female, and it is probably said that the female person tend to use more pronouns in writing of the text, and so these with the help of these we can identify, we can have some pronouns as features, and then we can identify that this text is written by a female, and similarly we can identify some other kind of features that are written by a male person. So this is a sentiment analysis, whether a movie review is positive or not. So we can have a review of anything, we can have a review of a product, we can just assign it the positive or negative sentiment to anything, right? So these are some kind of comments that are given by the people. So these are actually the reviews. So this unbelievably disappointing, this is can be marked as a negative review. This can be marked as a positive review. Richly applied satire and some great, we have this word as great, and here we can see that disappointing, and then again we have the greatest, and then we have this word pathetic. So based on these again features, we can say that this is the positive, this is also positive, this is the negative one. So again each of these we assign. So this is a particular single review, this is a single review, this is a single review, and this is a single review, right? So we can again mark them as positive and negative, and then we can apply the text classification. Similarly, we can do the document categorization. So document categorization is assigning the category to a given document. So this is suppose a particular scientific document, so to which category among these we can assign, or we can see that this particular document belongs to, right? So if this is a medical document, it can belong to any of these, right? So we can now say that text classification is actually the task of assigning the topic category to a piece of text or a document, right? So we can say that text classification is the task of assigning subject categories, like task of assigning subject categories, topics or genres, which can be specifically in technical terms is called as class, right? So from where we are getting the term classification. So the task of assigning, either it is a category or it is a topic or it is some genre or it is some sentiment or some any kind of class, so, right, to a given document or piece of text. So that piece of text may be tweet also, right? It may be a complete document, it may be complete news article. So there are different applications, and language identification is again some some of the different documents are written in different languages. So this is written in English, this is written in Spanish, this is written in say French. So these are the different languages, but these languages also share the characters among themselves, right? So this is Spanish have some different character set, but the character set among these, they are shared with each other. So that's why this problem becomes a difficult problem, right? So this kind of problem is also in text classification. So how do we define the text classification? We say we have a document D, we have a fixed set of classes, right? So we have a given document D, and then we can have suppose we are doing for spam detection, so we have this particular set of classes, that is class C1 may be spam, class C2 is not spam, and then class C3 may be neutral, right? So there can be different number of classes. So we have a fixed set of classes. We cannot change the number of classes. Later on we say that I am having some new class that is little spam or something like that, or highly spammed, right? So this cannot be done at a later stage. We need to initially define what are the classes and we need to fix it. And then output is that this document D will be assigned a predicted class C that may belong to these classes, right? So we can go for different approaches. The basic approach that comes into a mind of a person is intuitively that we can just define some rules. We can define, or we can write some rules, hand coded rules, right? That means we may define a rule, we may see some of the email addresses, and then we can just match with those email addresses and specify that this is always coming from a spam, and so we mark those particular email addresses as blacklist addresses, and then when we get the document we just compare the email address, right, with these blacklist ones, and then we can say that this particular email is spam or not, right? Similarly, or we can have some in text, we can have some kind of words, some kind of piece of text, again we can match with them, we can apply some kind of match with patterns, maybe using regular expressions, right? So we can do write some rules, right? We can define a list of rules. So these list of rules may be very, as many as we can write. So there is nothing small number of rules or large number of rules, but we can definitely intuitively think upon by seeing both kind of text, the spam text as well as the non-spam text, and then we can write some rules. And then rules, in general we mean to say we have to apply this kind of thing in this: if email is equal to, suppose we have a list of, or we can say just blacklisted email, right? then again here we can have some other rule, then again we can have here some other rule, then he, so if these all these rules are come true for a positive, for a spam, this rule belongs to a spam email, this also rule. So if all these rules come true, then we can say that finally it is a spam, right? Or we can also do some kind of if else nesting, and then we can arrive finally that whether the particular piece of text is a spam or not, right? And the accuracy here is quite good, but the problem with these kind of rule based methods is that these are very expensive to build and maintain. So why do we require this kind of building and maintaining, is that because as the time passes on, the characteristics of the text change, the characteristics of the text or document changes with time, right? So if we have some kind of email addresses that we blacklist, so we will see again that some new email addresses arrive with the passing of time. So we need to again add this blacklist new spam email into this list of email again and again, right? So now there has to be some again manual intervention in this process, so that every time I see a new email, I add it in the list of email and I again modify this program, right? So this turns out to be very expensive, as well as it turns out to be non-practical also. Every time some kind of a new piece of information is coming in the spam tag, so we need to add it with this, right? So this thing, and depending upon the domain in which we apply this problem, whether we are applying this problem into particular area of emails. Now emails may be belonging to some organization, emails can be some general emails like Gmail, Yahoo, etc. So the problem becomes more challenging when we apply it to a domain, and it's not possible to again maintain and build these handcrafted rules again and again, right? And this kind of thing becomes impractical in current scenarios. But initially when this problem was introduced, the spam classification problem, then this rule-based algorithms were quite efficient and they were quite taken as quite good. But as by the introduction of machine learning, this rule-based as well as the machine learning algorithms are combined together to bring out some kind of new and strong and powerful rules, powerful methods, or powerful systems that are able to detect the mail as spam or not. Right, so we have the supervised machine learning methods with the help of which we try to solve this kind of problem. Now initially we said that we have only a document and a fixed set of classes with the help of which we can solve this problem, and the solution was the handcrafted rules. But if we are using the supervised machine learning framework, then we also require, apart from the document and the set of classes, we also require a training data of M hand labeled documents. Hand labeled documents means that some documents must be assigned their categories by some human being. So if these are the documents, so these documents D1, D2, D3, D4. Now how would some machine know that this document belongs to a particular class? Right. So this document has to belong to some class. So I say that this is a spam. So there is some human involvement here in the training data every time. In any of these training data, some person is always assigning the classes. So I say this as a not spam, this as not spam, and this as spam. Right. So there is a training data of some M documents that are hand labeled in this kind of notation, so that we are having a document 1 which is assigned the category of class 1, document 2 which is assigned the class 2, document M is assigned class M, in this way. And there is some human involvement here, and specifically this is called as the annotation. Annotation means assigning the classes to a given document, right? And this is a particular prerequisite of any kind of classification method. So the classification method requires that the data has to be labeled, data has to be annotated. So human annotation or human labeling. And when we get a data that is called as human labeling, so that data is called as gold standard data, and which is assumed as this is the highest quality of labeled data. Right. And this is also called as, every time when we compare it with the predicted results, this is also the true data. And then we have these three things as an input to the algorithm, supervised learning algorithm. Then the supervised learning algorithm produces an output in the form of a classifier, this classifier gamma. Right. So let's see what's the architecture here. So this is the algorithm, and we give input here the training data. So this algorithm is producing, we give the training data and we also give the classes, set of classes. So collectively, I mean to say that this is the labeled data. So this actually produces a classifier gamma, right? And then we give this input document D to this classifier gamma, and this produces the class. Right. So this we get a classifier gamma, which is a kind of mathematical or statistical or probabilistic function, or any kind of function that maps a given document to a given class, to a fixed class, right? So we give input the document, it produces the class. So we can also assume this gamma a kind of function, right? So there are different kinds of classifiers. We have the logistic regression support vector machine, k nearest neighbors, and in some of the more sophisticated we have the hidden Markov model. We have the conditional random fields, and then we have the latest ones, long short term memories, that is the LSTM. right? So these all are some kind of frameworks that are applied again into classification. So we will be seeing this, what is actually the naive Bayes classifier. So naive Bayes classifier is actually based on the Bayes rule or Bayes theorem, and it depends upon the document representation, which very at the beginning level we can apply using the bag of words. So there are different document representations. This is our representation or document. The very elementary representation is the bag of words, and apart from bag of words we can also have n-grams, right? So this bag of words is actually unigram model, right? So we can have n-grams, we can have document, so word vectors, or popularly called as word embeddings, and we can have some kind of hybrid representation. Hybrid representation means the collection of all these similar kind of things, different representations, the collection of different representations. So we have this hybrid representation. And what is the Bayes rule? Bayes rule is that P of A given B is equal to P of A comma B upon P of B. So this is actually the conditional probability. Probability of A conditioned on B is equal to probability of A and B divided that by the probability of B. So we are having a class, a set of A, alright, and then we have some kind of this another set that is inside B. So we do is, what is that, when we take the probability of A given B, so we only consider this B part. It means that we are looking into some smaller set, so we are dividing the combined probability of A and B, or it could be also like this one, right? So we are just considering only that portion in which we are conditioning on, right? Similarly we can have the vice versa, P of B given A, P of B given A is equal to P of, again, B comma A can also be written as same as A comma B. So while now again we can eliminate this P of A comma B from here, so this we will get as P of A given B dot P of B divided by P of A. Right, so I am replacing this P of A comma B with this thing, and I am putting it here. Right, so I get P of B comma A, B given A as P of A given B dot P of B divided by P of A. So this is actually the Bayes rule. So we will see this later in detail. So we have a function gamma, and we give the gamma with this document, right? So we give the function, we have the function gamma here, right? So we have this kind of model. This is actually the model, and in mathematical terms we can also call it as a function f of x like function. So we give the value of x here, we get some value of fx as y, right? So it is a mapping of x to y. Similarly we have a mapping of D to C. We give a document as an input, we get a class. So we give a document here to the function gamma, and we get the class here, right? So whether this is a positive sentiment or a negative sentiment, or this is this is a spam, and this is not a spam, right? So this is particularly the example of sentiment analysis. This is saying that this is a positive sentiment, this is the negative sentiment, this is a document we need to identify. I love this movie, it's a sweet. So you see that this is actually a comment or a review of a movie, right? The dialogue is great and the adventure scene. So we see that this particular document is given as an input, and with the help of which we need to calculate the given class C, right? So what we do with this document is that we again have to go for the representation of document. And then what is the representation of document is actually the bag of words, in simple terms, is called as the collection of words, right? So we will assume that this document is actually the collection of all these words, right? So when we represent this mathematically, so what I would, in simple way I will do is that I will make a table here, and I will just list down all these words in the tabular form, right? So I will list this as a list of words. So the bag of words actually here loses the word order. The problem is that it loses the word order. So I take all these words and I can just sort them alphabetically, and then you can just put them in a table, or you don't put them in alphabetical order, you just like put them in a table, like I love this movie and it's sweet, and so on. And I don't, again I take only the unique words here. I don't take the repeated representation, repeated words, right? So I am just taking here a tabular representation in which I see that which of the unique words are present here, right? And then I make this as a document representation. I mark all these unique words. I give some kind of code to these unique words. That can be one kind of representation. But in case of bag of words, I make bag of these words, and then I also write the count of these words, so that this can be considered as a bag. So this is actually a bag, right? So with this particular list of words, I identify all the list of words as a vocabulary V. So this, I can say that this is the vocabulary V, and I am having a lot more words like satirical, like humor, and then for a given document, say D, I will write down the counts of all these. So I will write the counts of, say, I is 10, love is 4, and this is 2, and movie is 8, and satirical is 6, and humor is 12. And if I am getting some other kind of document, I will be writing the same thing for the document D1, suppose. So I am writing the counts of these documents. So this particular is actually the representation of this table of numbers will be replaced by this text of words. So this tabular sequence of words, is actually called as the feature vector, right? So this is the feature vector. So if this is the document D, so this is the document D. So this particular column is the feature vector of D. If I have some another document D1, so that will be the feature vector generated by D1, right? So in case of documents, there are a lot of words that are not required. This the is not having any kind of information, and this R is not having any kind of information, and is not having, so this at. So there are a lot of words that can be eliminated right? So this we can remove all these words, right? So we may get a simpler kind of representation, right? So we only see in some kind of we can also we can remove some kind of irrelevant words, and the other way around is that we can see some kind of specifically significant word that are related with the problem. So in sentiment analysis we see that these particular words are of some significance, so we may take up only these words and get the count of these, right? So we may take only the important words that are related, that are significant to this kind of problem, to the sentiment analysis or to the movie reviews, and then we can leave out all the other words, and then we are left out with this kind of representation, right? So this is actually the final representation of this particular document. If we are having some another document, we may get some other values for, we may get 1 3 4 2 1 like this. So for another document we may get some other representation, right? Some other sequence of numbers, sequence of counts, right? So and finally this representation, with the help of this representation we may be able to assign the particular class to the given text, right? This may belong to the parcel, language, label, translation. So these set of words, if present in some document, right? So we may again see that this parser is present in most of the times. It is present in this category, NLP category of the documents. Again, this translation is present here, right? And the language is present here, right? So this parser is not present in any other kind of categories. So definitely some kind of algorithm will try to predict that any kind of will try to predict that this particular document is closer to this category, or it is having the highest probability to this category as compared to the other category. So if I give the calculate the P of document given NLP, so this may be the highest one, because we see that there are some in very abstract terms, or in just watching the words present in the documents, we see that there is a lot of matching here, and there is no matching, or there is little matching that is present with this one. So this language is also present with planning. So this P of document given planning may also be some value, but it may not be as high as compared to this document, right? Because collectively all these probabilities of all these words will be high, because their 3 words are matching, right? So what is the Bayes rule? So the probability of a class given a document is equal to the probability of the document given the class multiplied by the probability of the class divided by the probability of the given document. Now what is actually this formula? Let me elaborate this formula. So in probabilities we have only seen that we calculate the probability of the probability of like how many white balls are there in the collection of red, blue and white balls, right? So we say that what is the probability of white, so that's equal to the number of in a particular bag I am having these, say, some green balls, and I am having some white balls, and then I am having some kind of red balls here. So the probability of red ball is equal to number of red balls divided by total, right? So the probability of this red ball is equal to number of red balls is 3 and the total balls is 9, so we have the probability as 1 by 3, right? The conditional probability is something based on the condition, it's based on the condition. So what is the condition? The condition is that suppose we have another bag. This is bag 1 and this is bag 2, and then we also have some kind of some number of balls present here. We have these, and then we have some red balls. Now the scenario has changed. So in this case, when we calculate the probability with this another bag, the probability of P as red ball is actually the total number of balls, red balls is 4. Total number of red balls is collectively is 4, divided by total number of balls is 9 plus 5 plus 2 is 7, that is 16. So this is 1 by 4, right? But if I say I want to identify the probability of red balls in bag 1, so I am giving the condition now. So I am giving the condition. The condition is that P of a red ball given bag 1. Given bag 1. So now I am specifying the condition. Instead of taking the whole set, I am specifying some subset, and I will be looking for only that subset for calculating the probability. So this kind of probability is called as the conditional probability, in which I condition the given probability based on some kind of information, some kind of clue, some kind of small subset of small subset. So I condition it on this bag 1. So I will be now, for calculating the probability, looking for this bag 1 only. So this initially at this stage, when I am having both bag 1s and bag 2, and I want to calculate this one, probability of red ball, I assume that this is actually a collective only single bag, right? And I go for this probability. But when I have only this one, this I take as collectively. But when I'm involving these two bags, right, and these bags are present separately in each of the balls are present separately in each of these two bags. So I need to again specify which probability of red ball I am talking about. Am I talking about the probability of this collection of both the bags? So that is P of red ball only given nothing, or given as a whole. So this P of this red can also be written as P of whole set, P of whole, or it can also be written as P of nothing. So there is whole, it means that I am considering the complete set, and P of nothing means that I am not specifying any condition, I am not specifying any kind of criteria for calculating the probability. So this P of given bag 1 is, again, I am restricting the probability to this bag 1. So I will just see only this bag 1. I will look up only this part of the set for calculating the probability, which is again 3 by 9, right? Now let's see how we are getting this with the help of the total probability. So we have so let's first calculate the P of this given bag 2, right? So this bag 2 is actually this, we have only one red ball divided by 7. So these are the two different probabilities, right? And specifically, again, if we look into the other way around, we can also go on with calculating the probability of what is the probability of bag given red ball. So in this case, if probability of bag given red ball means the probability of bag one given red ball and the probability of bag two given red ball. Right? So what is the given? I am being given a red ball. Right? I choose from this. I from these collection of two bags. I just close my eyes and then I put up my hand. I don't realize that I'm putting my hand into bag one or bag two. Then I get a red ball. So in that case, whether that bag is bag one or bag two, right? So that's the problem. So I get two kind of probabilities. This whether the I'm getting the red ball, whether the probability of bag one, and whether I'm calculating the probability of bag two, right? So these probabilities can be calculated with the help of this Bayes theorem, right? So I am given with the red ball and I want to calculate the probability of the bag, right? So this is again the other way around. So this probability of bag 1 can be calculated as probability of ball red given the probability of bag 1 dot probability of bag 1 divided by the probability of this red. Right? So this is actually the prior probability of bag. In this we call this as prior probability of bag, and this is called as the likelihood of red ball, and this is the just the probability of or marginal probability of a red ball. So this probability of red ball is the probability of red ball just seen in the collection of these two bags. So that is initially we calculated as 1 by 4. This is 1 by 4, and the probability of this red ball given bag 1 is this is 3 by 9, and the probability of bag 1 again given these two bags as a whole is 1 by 2, because we are having only two bags, right? So this is finally this comes out to be 3 by 9 multiplied by 1 by 2 multiplied by 4 by 1. So this is 1 by 3, and this is 2 here. So this is finally 2 by 3. Alright. So if I am picking out I am getting a red ball while putting my hands into the collection of bags and closing my eyes without realizing that in which bag I am putting my hand, I get a red ball. The probability of bag 1 is 2 by 3, right? Similarly, we can calculate the probability of bag 2 given red, right? So probability of bag 2 given red is 1 by 7. This 1 by 7 into probability of bag 2 is again 1 by 2 into probability of red is again 1 by 4. So this is equal to 2 by 7, right? So since this is conditional probability, we can't do it like the probability of bag 1 is equal to 1 minus probability of bag 2, because we are conditioning on something, right? So we can have the formula that probability of bag 1 given red so we can have some formula that is called as the law of total probability, with the help of which we can find out that this probability is the part of which total probability, right? So we are not going into lot more those details. So I hope you must have been clear that what is actually this formula all about, right? So let's see now with this formula.